Hello, welcome to Peko Virtual School Geography lesson. Mr. Kasade, facilitator. We have been looking at maps in the whole of this chapter. We looked at what a map is, how we can find ourselves moving from one place to another, the importance of maps, the features, how you make measurements of area, distance. So finally today we're going to look at how we can find places and features on a map. We said that the surface of the earth and on maps.
No, we have described, let us just start here before we go very far. Mpe urudi kufunga. Their voice were sharp.
They were going.
They will be about to go.
Hello students, welcome to Peko Virtual School. All level geography, new one. Facilitated, Mr. Kasada is your facilitator. We have gone through maps in this chapter. The 2 or 3 lessons back, we started looking at maps, how we use maps, how we find areas in our community using maps, how we can measure distance, how we can measure area. And today we are going to look at how we find places and features on a map. On the surface of the earth and on maps, different features are found in different places, which we have already tried to look at before this lesson. To be able to use maps, we need to describe where these features are found. And in this lesson, we are going to try and learn how we can be able to do this, to find places and find features on maps. Let's take an activity, and we are going to take a look at this map below. It's one of the maps that represent topographic maps, which we use in map reading, and it's going to aid us in trying to identify features on the maps. So let us look at this figure, and we are going to do a number of activities. First of all, in case you have this map extract, we call this a map extract, or it is a topographic map. In case they tell you to identify any 3 or any legs found on this map. We can identify these legs by looking at them and then looking at what is written within those features. It could be a lake, it could be a town, it could be a road junction, it could be a swamp. And by looking at these legs, there are certain words which have been written. Or by looking at these features, there are words which have been written against them. For example, we have Lake Bisina written across this area. So it means the whole of this place is a lake. Then there is the lake there, which we've circled. Then we have swamps, we have roads, and along those roads we have different place names. For example, Kapiri, equally Kapiri sub-county. Therefore, we have noted that these features can be found using words which have been written either close to them or against them. And in map reading, these are called the place names or the place labels, or feature names or feature labels. Therefore, we can locate places, we can locate features on a map using the names or using the words which have been written against them, which we are calling the labels. Now, in map reading, in addition to using place names, we have another easy procedure of locating places, locating features on a map extract. And that procedure is called the use of the grids and grid references. And when you look at this map extract or these topography maps, you have a network of lines which have been drawn all over this map extract. These are called the grid lines. And when you take a closer look at them, we have lines which are vertical and we have lines which are horizontal. Now these lines keep crossing one another. They keep crossing one another at right angles. For example, if you have this line crossing this one at a right angle, so they are crossing each other at a right angle and they form grid squares. When we are calculating the area, we talked about counting squares which have been either fully covered by the feature or partially covered by the feature. So these squares that have been created by an intersection of vertical and horizontal lines are what we call the grid squares. These lines can help us to find features or to locate features anywhere on this map. And that process of locating and finding places on the map is what we are going to refer to as the grid references. And in map reading, we are examined against, or we are examined in what we call the grid reference method, not the place name method. Now we've said that these lines are both vertical and horizontal. The vertical lines are given a special name. They are called eastings. They are running from the north to the south, or they are running from the south to the north, but they are called eastings. Reason? Because their numbers or their values increase as one goes to the east. If this is 80, this is 81, 82, 83, 84. So the values are increasing as you go to the east of the map, or the right hand corner, or the right hand of the map. So that's why we call them eastings, because their values are increasing as you go to the east or to the right. Then the horizontal lines, which are running from east to west or west to east, these ones have a special name and they are called northings. Reason, just like the eastings that are increasing to the east, the horizontal lines increase to, or their values increase to the north, such that if this is 86, this is 87, 88, 89, 90, as we go upwards, or as we go to the north. So they are called northings because their values increase as you move to the north on the map. So that is, these lines are the ones we use to locate places under what we are calling the grid and the grid reference method. Let's take an example. We have places, or we have points which have been located in our grid squares. This was extracted, or we've tried to extract this from a representation of what we've already seen on the topographic maps. So we are having vertical lines, and these vertical lines are increasing as you go to the east. For example, from the left corner we have 32, then 33, and they increase. By the time we come to the right corner, it is 40. So they are increasing eastwards, and we call them eastings. Then our horizontal line, the bottom line is 20. Then as you go to the north, the values increase 21, 22, and the top line is 27. So the vertical ones are called eastings, while the horizontal ones are called northings. So each line is identified by two figure numbers which appear in an ascending order. So in order for us to locate places or features, we first read off the eastings, and then after reading off the eastings, or writing the eastings, the two figures of the eastings, then we read the northings, or the figures written on the northing line or the horizontal line near that feature. That is how we state the location. In order for us to remember that formula, that we first read eastings and then northings, let's take this, and you memorize this, that in order to remember, we can say along corridors, or along the corridor, and then up the stairs. So you're moving east, or you're reading the easting first, and then up the stairs you're reading the northings after. So in case we want, for example, to locate point A, we are going to read the easting, or the value of the vertical line before that figure, and then we read the value of the horizontal line below that feature. So it is along the corridor and then upstairs. That is something that will help you to remember that you're reading off eastings first and then northings. Therefore, the number formed by these eastings and northings is what we are calling the grid reference. So when we combine these two figures and those two figures, what we get is what we call the grid reference, and it enables us, or it helps us to locate places. For example, we can locate feature A, we can locate feature B, we can locate feature C and D, and that process is what we call the grid reference process. This grid reference consists of even numbers, and these numbers are similar to the coordinates that we use in mathematics: horizontal axis or x-axis and y-axis. So those coordinates are similar to our grid numbers, the easting numbers and the northings. The grid reference is divided, or the grid reference figures are of two types. We have what we call the 4-figure grid reference and the 6-figure grid reference. The 4-figure grid reference takes into account this grid reference, this grid line value and that grid line value, or this grid line value. So when you combine, for example, 32 and the 23, you come to, or you'll get 4 figures: 3, 2 and then 2, 3. So the 4-figure grid reference will be 3, 2, 2, 3. That would be, those will be 4 figures. Then the other type of grid reference is what we call the 6-figure grid reference. And a grid reference is got by stating how far east and north the feature extends, how far east and how far north that feature extends. For example, if you're looking at A, from 35, how far does it extend eastwards? From 22, how far does it extend northwards? Likewise, point B, or feature B, from 32, how far does it extend eastwards toward 33? And from 23, how far does it extend northwards towards 24? So by stating the 6-figure grid reference, we are exactly getting to the actual location of the feature. The 4-figure grid reference only gives us the estimated location, or in which grid square the feature or the place exists. For example, A or C, the feature C is located in the grid square 39 easting, 20 northing. But for the 6-figure grid reference, we are going to be exact, that after looking at 39, that is your starting point, we have to move until we come to feature C. After starting from northing 20, we shall have to move northwards towards 21 until we get to feature C. Therefore, we shall have 6 figures, the 2 eastings and what we shall count to get to C, and the 2 northings, and the third we shall count towards 21. So when we add the 3 eastings and the 3 northings, we come up with 6 figures to make a 6-figure grid reference. For instance, we are saying that in this figure 3.10, point A is lying to the east of grid line 35, and D is lying to the north of grid line 22. Therefore, if you're stating the 4-figure grid reference for point A, it will be 35, which is lying to the east, and then 22, where it is lying to the north of 22. So the 4-figure grid reference of point A is 3522. That is a 4-figure grid reference. However, like have said, we can find and state the position of features using a more exact grid reference, which we are calling the 6-figure grid reference. And how do we do this? We can get to this by adding a figure to the easting and adding a figure to the northing of the 4-figure grid reference. So in the 4-figure, we had two figures for easting and 2 figures for northing. To get to 6-figure grid reference, we shall add 1 figure to the eastings already noted and 1 figure to the northings already noted. So the 3rd figure of each reading is 1/10 of the whole number. And to get this, we divide the grid square into 10 equal parts or equal small squares, both along the eastings, and 10 equal small squares along the northing. And this is an illustration that we have the vertical lines, we have the horizontal lines, we have the eastings, which is along the corridor, and then we have northings upstairs. Easting 61, 62, 63. So between easting 62 and 63, we can divide this space into 10 equal parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this will be 10, from 0 to 10. Then northwards we have 0, and then we count up to 10. So these small squares or these small lines will help us to identify the 3rd easting and the 3rd northing. That if you want to get, for example, to this location, you're going to start from easting 62. So you write 62, and then to get the 3rd easting, you count either the squares or the lines. So if you're counting squares, you'll count 1, 2, 3, 4, 5, 6. So it means you have moved 6 squares from 62. So 6 to, we add 6. Then the 0 line for the northing is 33. So we shall count from 33 upwards, up the stairs. So we count 1, 2, 3, 4. So we've moved 4 steps northwards. So the 3rd northing becomes 4. Therefore, to write the grid reference, we shall write 62 as the easting we've read off first, 6, and then northing 33, we've counted 4, so we add 4. So our grid reference will become 626, 33, 4. So we are saying that the features we are trying to locate will lie in any one of these tiny squares. But still, we remember what we've said, that we move first along the corridor, that is the eastings, and then upstairs. So we work out the exact number or the extra 3rd number to put to the 4 figures, and then we shall get a 6-figure grid reference. So this is what I've been emphasizing or explaining, that from 62 we are moving eastwards, from 33 we are moving northwards. So 62, then we count the squares up to 6. Then 33, we count the square northwards, and we shall have 4. Therefore, the 6-figure grid reference of this feature is 626334. So that one becomes our 6-figure grid reference, which is an improvement of the 4-figure grid reference. Therefore, I want you to look at this figure 310, which is an extract from the other map, and then in your books try out to state the 4-figure grid reference of the remaining features or the remaining points. We have point B, we have point C, and point D. So what is the easting to the left of point B? It is 32. What is the northing below point B? It is 23. I've already tried to illustrate that. So the 4-figure grid reference for point B would be 32, which is to the left of B, and 23, which is below point B. So try to find out for C and D for D, the 4-figure grid references. Then you're going to equally try out and find, get a ruler and find the 6-figure grid reference of point A, B, and C. Point A, B, and D, C. Already point A, the 4-figure grid reference, we've said it is 35, 22. Therefore, we shall divide this into 10 equal parts, equal squares, and then northwards into 10 equal squares, and then from 35 we count the number of squares up to that point. Then from 22 we shall count the number of squares up to that point. So find out, try to work out and establish what is the 6-figure grid reference of point A, point B, and point C. Then after that you're going to write 2 sentences explaining advantages of using the 4-figure grid reference, at least 2, and then the 6-figure grid reference to locate places on the map. I've already given one advantage of the 6-figure, that it gives the exact location or the accurate location of a feature on a map. That is an advantage of the 6-figure grid reference. So after you working out this, try to write 2 sentences indicating or explaining the advantage of the 4-figure grid reference and the advantages of the 6-figure grid reference in your notebooks. So that is one way of locating places on maps or locating features on maps using the grid reference method or using grid references. 2, we can equally locate places on a map using the compass direction. And to understand this, I would just inquire, how would you describe to a friend the route from your home to the nearest trading center, assuming you're directing your friend on phone? You'll tell him, I imagine, that when you reach a certain feature or a certain point, you turn left or turn right. Turn left and then move ahead. When you reach this house, you turn right, and then as you slope, the first house to your left or to your right is where I stay. That is how we, in our day-to-day living, direct our friends on phone, especially if you want them to come and visit us. However, when we are using maps, we can do this in a better way by describing the routes on maps using what we call the compass directions. So in map reading, or when we are using map extracts, we can locate places, features, not using the words turn left, turn right, but by using the compass direction. In the first procedure, we said we can locate using grid reference, points, numbers. Here we are using the compass direction. Let's remind ourselves, when you are still in primary, you must have looked at a compass. So can you explain what you understand by a compass? What is a compass? We said a compass in primary. A compass helps us to locate places from another using the cardinal points. Therefore, after explaining what you understand by a compass, can you draw a diagram of that compass, what you used to draw? How many points how many major points do we have on a compass? We said we have 4 major points. And which ones are they? North, east, south, and west. So can you draw that compass showing those 4 points? So in your notebook, if you finish drawing, those lines you've drawn are not the actual, or is not the actual compass, but we can call it, or we call it, a compass rose or a direction finder. That is how we call it. It's not a compass. To be able to use the compass to find the directions more accurately, we can further subdivide what you've drawn, the 4 cardinal points. We can further subdivide them into other 4 directions. So the original were 4. Then we can subdivide further those sections between, for example, north, east. We divide into 2. Between east, south, we divide into 2. Between south, west, there is a subdivision. Then between west and north. So we had 4 original. Now we have added 4 to make 8 intercardinal points. So those 4 that we have subdivided between the first 4 are what we call the intermediate directions, or what we call the intercardinal points. And there are 4. And these ones include northeast, meaning the line between the north and the east. Southeast, the line between the south and the east. Southwest, line between the south and west. Then northwest, which is the line between the west and the north. So when we add these 4 to the original 4, we come up with an 8 cardinal point compass rose. Let's note that these intercardinal points combine 2 directions. For example, here we have north and east to get northeast. So they combine 2 directions. For example, northeast, meaning that you move east and then north. You move east and then north at the same time. So in other words, northeast lies between north and east. We continue in our notebooks. How do we subdivide the compass? This is our third activity. We've already explained this, how we get the 8 cardinal points. So we first draw the 4 cardinal points: north, east, south, and the west. Then between north and east, south and west, we subdivide. Then between west, north, east and south, we also subdivide. So between north and east, we have northeast. Between east, south, we have southeast. Southwest, we have southwest. Then north and west, we have northwest. So this is what we call the 8-point compass rose. So I want you to copy this compass rose into your notebooks and do another activity. I want you to use a protractor. You measure and state, 1, the angles between the nearby cardinal points or directions. The angles between the cardinal or the nearby cardinal points. So what is the angle between north and east? What is the angle between east and the south? What is the angle between south and the west? You use a protractor. You note in your notebook. Then I want also to measure the angles between the cardinal directions and the intermediate directions. For example, what is this angle? How many degrees are between north and northeast? How many degrees are between northeast and the east? Then I want you to divide the cardinal directions and the intermediate directions halfway using straight lines and measure the angles of each. So between north and northeast, then between south and southwest, I want you to draw a straight line in between. Then between northeast, east, southwest, west, you also draw a straight line in between. And then measure what is that angle you've created between north and that new line, between the new line and northeast, between northeast and the new line, between the new line and the east. So write those angles. Then what is the name of these new directions that you have created by subdividing the intermediate directions? For example, what is the direction between north and northeast? What is the direction between northeast and the east? We said northeast means you have moved north and east at the same time. Therefore, what would be this new direction? It means you're moving north and northeast at the same time. Therefore, for example, here the new direction will be north, then northeast. So the new direction will be north of northeast, or n north, northeast. Then between northeast and east, what will be the direction? It will be that you've moved northeast and east at the same time. Therefore, it will be northeast, east. So can you write the new directions that you have created by subdividing the intermediate directions? After doing that, you'll come up with a compass rose with 16 cardinal points. So this one becomes, or this is called, the 16-point compass rose. And the new directions would have got combined 3 directions: north, northeast. So you've moved to the north and northeast at the same time. So you'll have north, northeast. Northeast of east. So these enable us to find and describe the directions of all places and features accurately on the map. For example, we can say from Kampala, Mukono is to the east. Or we can say Mukono lies to the west of Jinja. Or we can say Jinja lies to the east of Kampala or northeast of Kampala. So that one, we are getting direction and directing someone accurately by using what we call a compass rose, which can either have 4 cardinal points, 8 or 16 cardinal points. But the major 4 are north, east, south and west. Then when you subdivide those 4, you get 8. When you subdivide the 8, you get 16. And those accurately help us to find places and features on the maps. So to determine the direction of one feature or place from another, the procedure we follow is we draw a compass rose at the point from. Remember, we have one feature or one place from another. So we draw the compass at the point from which you want to describe the direction. So if we say find the direction of point A or feature A from feature B, it means the compass rose is going to be drawn at B, and then we determine the direction of feature A from feature B. If it is find the direction of feature B from A, it means we draw the compass rose at A, and then we see, according to our 16-point compass rose, what would be the most appropriate direction of A, of B from A. So draw to determine the direction of one feature or place from another. We draw a compass rose at the point from which you want to describe the direction. Then a straight line in pencil is drawn connecting the 2 points or the 2 places, place A for example and place B. Then we read off the direction corresponding or closest to the point whose direction you want to find. And I've already told you, or I've said that if it is A from B, then you draw a compass at A, compass at B, and then you connect using a straight line. Then using the 16 cardinal points while standing at A, move until you come to the line going at B. So you could determine which direction it is. So that one is the most accurate method, or one of the other accurate methods we can use to locate places on a map extract. 3, we can locate places using another method of bearing. So you can describe the position of a feature or place from another using their distance apart, but in form of angles. So bearing is the distance from one place to another in degrees. That is what we call an angle. So in form of an angle. The angle is measured clockwise from the north line. This angular distance is what we are calling the bearing. So how far apart, or what distance apart, is one point from another, is one feature from another in terms of degrees. That is what we call bearing. And it is stated with 3 figures. it is stated with 3 figures. If the angles are less than 100 degrees, we write a 0 before what we have measured, before the angle we have measured. For example, if the angle is 45 degrees, then we write a 0 before we write 45. So we write 0 45 degrees instead of 45. If it is above 100, we write the actual figure that we have measured, maybe 110 degrees, 101 degrees. So to understand this better, we follow the steps below. To determine the bearing of one point from another, we draw a compass rose at the center of the point from which you want to determine the bearing. That is 1. 2, we draw a line joining the 2 points, and then using a protractor we measure clockwise the angle between the north and the line that we have drawn, which is joining the 2 points. So if you are finding the bearing of A from B, we are going to draw compass rose at A, compass rose at B, and then we join the 2 with a straight line. Then at B, from the north, we measure using a protractor clockwise until we come to the line connecting to point A. We are going to do this by looking at the illustration below. So in figure 313, we have an illustration of measurement of bearing of A from B and of B from A. So the bearing of A from B, B is here, A is here. So the bearing of A from B is the angle measured in red, or using the red arrow. So it becomes 0.65 because we are measuring at B. That is where they said from. Then the bearing of B from A, if you're standing at A, in order for you to go to B, you're going to turn clockwise from the north into 90 degrees plus 90 degrees plus 45 degrees. So 180 or 65. So 180 plus 65, you get the bearing of 245 degrees. So they have told us we measure at the point from. So from B, we stand at B and measure. From A, we stand at A and measure, but clockwise. So that is an illustration of how we locate places using bearings. Let's follow this activity and we try to find the bearing for the different features. So in your notebooks, can you determine the bearing of the cement factory from the quarry in Tororo municipality? We have the factory. The factory is here, and then we have the quarry. We have 2 quarries, so you can get the bearing of the factory from this quarry. So we have 2 places. Cement factory is A, the quarry is B. So we identify A and B, we draw compass rose, we draw a compass rose, we join using a straight line, or we first join using a straight line, then we draw a compass rose at B, we draw a compass rose at A. They have told us what is the bearing of the cement factory from the quarry. So where are we standing? At the quarry. So from the north, we measure clockwise until we come to the line going to the factory. That is 1. 2, they may tell us to find the bearing of Tororo College from Tororo Rock. So we have Tororo College here, we have Tororo Rock there. Your work is, or will be, draw a straight line connecting Tororo College to Tororo Rock. Draw a compass at Tororo Rock, draw a compass at Tororo College. Then they are telling us to get the bearing of Tororo College from where? Tororo Rock. So we are going to measure clockwise from this until we come to the line going to Tororo College. So can you work out that? Then they have told us to find the bearing of the forest south of Tororo Rock, which is here, because Tororo Rock is here, the southern direction is here, from Rubongi Road Junction. What is a junction? A place where two roads meet. So you just look for the place name. So Rubongi is here, the road junction is here, the forest is here. So we are finding the bearing of this forest from. So get a ruler, join these 2 points using a straight line. Then at the forest we draw a compass. At Rubongi Junction we draw a compass rose. Then from the north we measure until we come to the line moving to the forest. So that is, I want you to try out this in your books and find the bearings of those features. So that is how we can locate features and places on map extract, either using the grid reference, using the direction or the compass direction, or using bearings. However, on the bigger maps, because the topographic maps are small, but on the bigger maps we don't use the grid references. We use latitudes and the longitudes. We use latitudes and the longitudes. So we are saying that the maps you have used above as all show small areas with great details. These are called large maps. But we have maps which show large countries, large areas like countries, regions like East Africa, or regions like the whole world. And these show relatively larger area, so that the information they put there is little. They are not as detailed as the topographic maps. They will not put where you find a church. They will not put where you find a school. They will not put where you find a mosque and others. So they have little details, and these are called the small maps. Small maps because they are covering a larger area on a small piece of land. Large maps because they are covering a small area on a piece of paper. So in case we want to locate places on the small maps, then we make use of latitudes and the longitudes. If you want to locate places on large maps, which we are calling the topographic maps, then we use the grid reference, we use bearing, we use the compass direction. So when we want to describe the exact positions or features of places on small maps, we use what we call latitudes and the longitudes. And in primary, you must have looked at the lines of latitudes, and we have an illustration. That latitudes are these horizontal lines, which are running from the south of the earth to the north. They're running from the west to the east, but they go northwards and they southwards. And among these lines, we have this major latitude, which you have, or which was named. Its name is the equator. And this equator is dividing the earth into two: the northern part and the southern part. The northern part and the southern part. And they are running from west to east, but dividing the world into two: north and the south. That's why you see from the equator we have degrees, or we have numbers upwards, 30 degrees north, or numbers southwards, 30 degrees south. So in order for us to understand the latitudes, we have to first know, what do we understand by a latitude? We've noted that these are lines running from west to east. So by definition, we can say a latitude is an imaginary line running from east to west or west to east. But just like northings, they are numbered northwards or southwards. Then in your books, you can write 2 sentences to explain what latitudes are, and then suggest how lines of latitudes are determined and marked on the map. So I've told you they are marked running from, or they are determined, they are marked running from west to east or east to west, but their numbers are increasing either as you go north or as you go south. And the major latitude is the equator. So latitudes measure how far north or how far south of the equator a place is located. And the equator is the starting point, or is the major latitude, and therefore it is the starting point while measuring latitudes. For this reason, it is marked 0 degrees, so it is the 0 degrees latitude, and it is dividing the world into 2 parts: the northern part and the southern part, like we've seen in figure 317b. Do you remember how they call these parts? The northern part of the world above the equator, and the southern part of the world below the equator. Do you remember how they are called? Try to remember that. What is the name of the northern part north of the equator? What is the name of the southern part south of the equator? So these latitudes are numbered in degrees, and they increase as we move further away from the equator, all the way up to the 90 degrees latitude, which are called the poles. So apart from the equator, we have other major latitudes. We have the Tropic of Cancer in the north at 23.5 degrees. We have Tropic of Capricorn in the south at 23.5 degrees. Then we have the poles, which are at 90 degrees. So we have the North Pole and the South Pole. So that is what we call, or those are what we call latitudes. Then we can equally allocate places using longitudes. And these are imaginary lines running from the North Pole to the South Pole. They are vertical. However, their values are their values increase either as you go to the east or as you go to the west. That is why you have 20 degrees east, 20 degrees west. So they are running from the south to the north, or from the north to the south, but they are increasing either as you go to the east or as you go to the west. So these are called lines of longitude. Now the major longitude is the Greenwich meridian, and the Greenwich meridian divides the earth into two, the western part and the eastern part. So how the prime meridian divides the earth? So into two parts, the western part and the eastern part. So longitudes measure how far a place is east or west of the major vertical line, which is called the prime meridian, or what we call the Greenwich meridian. So the prime meridian runs through Greenwich in England, and because of this it is also called the Greenwich meridian, because it cuts through a place called Greenwich. It is the starting point for measuring longitudes. The starting point for measuring longitudes, and then you measure either eastwards or westwards. And just like the equator, it is marked 0 degrees, and it is the major longitude. It divides the earth into two equal parts, the western part and the eastern part, and we've already seen that in figure 3.5b. The importance of this line is determining the time zones, or time, that different places in the world have different timelines or have different times. For example, when it is 2 o'clock in England, it is 4 o'clock in Uganda, meaning that Uganda is 2 or 2.5 hours ahead of England. Then, so as we move to the east, there is an increase in time. When we move to the west, there is a subtraction or a decrease in time. That is why when in Uganda it is 7 a.m., in North America or in places like New York, which is to the west of the Greenwich, it is still night. When it is night in Uganda, it may be day in Japan, just because of the difference in location away from the prime meridian or the Greenwich. So the major or the most important function for the Greenwich is determining the time of different places. If you are to the east, time increases by 1 hour every after 15 degrees. If it is to the west, time reduces by 1 hour for every 15 degrees. So that is what the major longitude and its importance. So let us explore how we use the latitudes and longitudes to locate places. So lines of latitude, lines of longitude also form a grid system on the small maps now. For example, the world map. So we looked at the grid system and we identified how we locate places. So even these latitudes and longitudes form a grid system. And just like we read the grid reference, If you are locating places using latitudes and longitudes, simply read the latitude first, along which a place or a feature lies in degrees, and then read the longitudes along the corridor and then upstairs. So we are reading east the latitudes first and then the longitudes. As the point where the two lines meet, we state the two numbers. These will give us the coordinates of those features. For example, when we look at the feature or the map below, it is a sketch map of Uganda showing the different towns. When we take Kampala city as an example, it is lying almost close to the equator, which is 0 degrees. So Kampala by latitude is located 0.2. So we've moved 2 steps from the equator to Kampala, north of the equator, because it is in the north, the northern part. And the latitude, we have 32. Then we are moving 3.5 steps from longitude 32. Therefore, by location, we can say the position of Kampala is 0.2 degrees north, 32.35 degrees east. If we want Fort Portal, we are having the equator, therefore it is 0 point, then we count maybe 4 degrees north and 30.21 degrees east, because Uganda lies to the east of the Greenwich meridian. So this is how we can identify and locate places using the latitudes and the longitudes. I want you to do this activity and demonstrate how you can use latitudes and the longitudes to find places. For example, using the map of Uganda or figure 3.6, can you find the position of Arua? You state the latitudes and the longitudes. Is it in the south or the north of the equator? Is it to the east of the Greenwich or the west? Then the location of Lira, Mbarara, Soroti, Moroto, and the Jinja. To illustrate this more, you can make use of an atlas. So can you get an atlas and look at the world map, which is showing the political units of countries, and using that map, can you find out lines of latitude and longitude between which countries like Angola, Chad, Australia, Ecuador, Uganda, Egypt, India, and Iran lie? Then can you find the latitudes and longitudes locating the following, or can you find the cities which lie at the following locations using your atlases? 5.19 degrees north, 4.01 degrees west. That is 1. 2, 33.56 degrees south, 18.28 degrees east. 38.45 degrees south, 62.15 degrees west. 0.19 degrees north, 32.35 degrees east. Then 1.20 degrees north, 101.45 degrees east. Then 41 of 41.50 degrees north, 87.4945 degrees west. So can you find the cities which are located in those or between those latitudes? So those steps or those procedures or processes are the ones we follow while locating places on either small maps like the world map or large maps like the topographical maps. And in summary, in chapter 3 we have learned about maps, and we've said that we've noted that all human beings, including me and you, we move around not using drawn maps but using mental maps. Equally, we can move around, find places using the drawn maps. That is 1. 2, we have noted that a map is drawn in plan, as if you're looking at features on the earth directly from above. 3, we have noted that the objects or features are represented on maps using symbols, and then those symbols are described using the key. 3 or 4, we have also noted that all the features on maps are smaller than their real size because they are reduced using a scale. 5, we have identified that how to draw a map of the local area using symbols and the scales. Then we have also gone through how to use the linear or bar scale to measure distance and measure or estimate area and features on the real ground. You can do this using the different methods like we saw in week 5 and 6. Then we have seen the difference between the small scale maps and the large scale maps. Small scale maps, those are the large areas which are represented on small pieces of land or pieces of paper. Then the large scale maps, those are the large areas which are represented on, or those are small areas which are represented on pieces of paper. For example, the topographical maps. Then we have equally learned how to find the position of features on maps of the different scale. So small scale maps using latitudes, longitudes, the large scale maps using the grid reference, compass, and the bearing. Thank you so much. I want you to practice on those few exercises that I've given you in your books as we prepare to look at them. Once again, I implore you always to have an atlas on you when you're revising and listening to this tutorial. 2, I always advise and implore you to always get in touch with us for assessment, for exercises, because it is the most important thing. That is what is important, because it will test how far you have gone and how much you have acquired and learnt out of these tutorials. So you get in touch every time you get a CD, get in touch with us, and then we or you pick the assignments. We encourage you to always attempt them on time, correct your books, we make revision or we make assessment of those or that work, and then we give you the feedback. For example, over the different sets of exercises you've been doing, I have come I've come to note that much of your writing, or the writing of letters, is still lacking, where we say write a letter to your friend advising him or her on what to do, since or as he or she did geography as a subject. Some of you, or most of you, failed to write the meaningful letters, and on those letters I expected you, for example, to identify what do you learn in geography. Then, after learning that in geography, what can or how can someone benefit from the features, both physical and human, which are in his surrounding. So I expected you to have an explanation of that. That, for example, you would advise your friend that if you have forests in your community, since you did geography, I would encourage you to practice lumbering. Or if you have minerals in your community, I would encourage you to develop the mining, or to engage in the mining activity. So that is what, or some of the things that I wanted to clear up over the first assignments that you are subjected to. Otherwise, I wish you the best. Continue reading and continue attempting to, or answering those assignments that we